Our first function tries to find whether an integer is an odd value or not. The function returns true or false depending on the value. So the question says, write a function is odd that takes one value or one parameter, and the function returns true if the value is odd. We can solve this function using a one-line expression like this. Return n modulus 2 equal 1. And that's it. So the expression is going to be evaluated, and whatever the evaluation of the expression is going to be returned. So for example, here print is odd 10. This function should return false. It did. And if I run it again with 11, the function returns true, which is fine. If you want to simplify the code, you can say if n modulus 2 equal 1, return true, else return false. Let's test it. True with 11, let's give 6. And when the argument is 6, the function returns false. Function number 2, we need to write a function that is named getIntegerRange. It takes two parameters, start and end, that reads an integer from the user and validates it to be in the range between start and end values. This is a good function and very useful, and it can be used in so many examples. Let's see how we're going to do it. Def get integer range. Let's say start, comma, end. We need to ask the user to input a value within a certain range, validate it, and only returns it if it's within the range. So value is equal to integer input, enter, let us use format, enter a value between start and end. Good. So now once the user inputs that, we need to make sure the value is within the range. So how are we going to validate it? We're going to use while loop. While value is less than start or value is greater than end. In this case, the value is wrong, so we need the user to re-input the value. We go again and do the same input statement. It's a good idea to give the user invalid value message. Re-enter the value. So now the user was going to stay inside this loop until he inputs a valid value within that range. So if he comes out of the loop to line 8, it means the value is correct, so we're going to return it. So how we test it, for example, here, x is equal get integer range between 10 and 20. And let's say print x. So we're going to call the function in line 10, and it should be between 10 and 20. 99 is not valid, 44, now I am inside the loop. Until you input something that is valid, 15 is, and now we get it. You can test this for everything or use it in any function. For example, 0 and 4 if you are looking for GPA. 0 and 100 if you are looking for a course score. If it's a float, make sure it's a float. So you can actually write just, you can write float here. and return it. So now this one is going to work for a score of an exam. It can be used in many, many functions because we made the parameters variables here. So now let's say score between 0 and 100, 999 is not going to work, 34.5 is. So one problem is here. I forgot to change float in the lower one. So whether float or an integer doesn't matter. Now we talk about a function. So this is invalid. Now it's valid. That's it. So this function can be reused, and I will use it in many other examples in this tutorial. Function number 3, write a function named swap that swaps the values of A and B and returns both. Swap means A will take the value of B and B will take the value of A. And this cannot be done directly. Let's see how. So let's say def swap A comma B. You cannot say A is equal to B and B is equal to A and return AB. Here we are returning two values. Let's say if X and Y, X is equal 10 and Y is equal 20. If I say swap or X comma Y swap X, Y, there will be a problem with this solution. Let's see what the problem is. Let us print now. Print X comma Y. So one of them is going to be wrong. See, both are 20. Why? Because if you say A is equal to B, you're going to lose the value of A. After you do this step, A will be equal to 20 and B is still equal to 20. So you lost the value of A. You cannot get it back because you changed it to B. You cannot now set B to the lost value of A. So you need to store the value of A first in a temporary variable. That's what we call temporary variable. This is a very classic example. We can say temp is equal to A. Now the value of A is stored in temp. Then I can say A is equal to B. It's true that we lost the value of A now. However, we have already stored it in the temp variable. And now I can say B is equal to temp. So whatever was in A was stored in temp, then we got it to B. There should be some temporary variable here. So now if we try to run this, see now X is 10, Y is 20. We should get correct answer. So 20 and 10 now. Let us just make them 44 and 33. It should be now 33 and 44. But without a temporary variable, you're going to lose it. In Python, however, Python is a very powerful one. You can say A comma B is equal B comma A in one step. However, Python is going to do the temporary storage behind the scenes for you. Run. So it worked now here, 44 and 33. It was, and now it is 33 and 44. Let us just get names here or strings, Ali and Steve. So X is Ali and Y is Steve. Let's see what happens here. So now X is Steve and Y is Ali. Remember, you need to use a temporary variable. In Python, it's doable in this way. In other languages, if there is a workaround, do it, but usually you need to use a temporary variable. Function number 4. Write a function named count digits of n that receives an integer and returns the number of digits. So we need to know how many digits in that number. So let's say def count digits of n. Good. So count is equal to 0. Why? Because we're going to do this in a loop now. So we will use integer division. Remember, when you do integer division, the number of digits becomes less by 1 every time you integer division by 10. Let's see this. While n is not equal to 0, do what? Do this. Integer division by 10. So now n will be integer division by 10. Let's say n is 125. After you do it integer division by 10, it becomes 12. If you divide 12 integer division by 10, it becomes 1. If you integer division 1 by 10, you get 0. So see how many steps we get here? 3 steps. 3 steps will give us the 3 digits of that value. And I increment the counter every time before I reach 0. And I want you also to see what is the number now. So let us just test it before. Print count digits of whatever values here. 6 digits. Look at the numbers. First time, second time, third time, fourth time, fifth time, and sixth time. So what we did here, we integer division the number by 10 6 times. Every time you integer division any value by 10, you lose a digit. You lose a digit. Let me just do it before. And we forgot one important thing. We forgot to return count after the end of division. So return count. So now let us run it with the same value. Here is our number and it returns 6. So I'll put this again inside here and look at the result. This is our number, integer division by 10, twice, thrice, fourth time, fifth time, sixth time. So after 6 times, the value becomes 0. Because when you integer division the last digit by 10, you get 0, whatever the digit is. So you keep integer division until the value becomes 0. If you need the value n, for whatever reason, you can make a x is equal to n and do this on x. Sometimes in your code, you don't want to lose the original value of n. In this function, we don't need to. However, if you need the value of n after the loop, make sure you use a copy of it inside the loop. So after the loop, you still have the original value of n. Run. So now we get the same thing. Next function. Write a function named getMax ABC that receives 3 integers, ABC, and returns the largest value. Classic example. Def getMax A, B, C. One way of doing it, we can say max is equal to A, then do if statements, 2 separate if statements. If B is greater than max, then max is equal to B. Many students make mistake here, they use else. No, it's another if. It has nothing to do with the, if B is greater than max, it doesn't mean that C is not. Another if C is greater than max, then max is equal to C. And return max. So starting with this chapter, functions, avoid using max because max is one of the standard functions in Python. So let's call it largest, for example. So largest here, I'll just replace it, okay, with largest and return largest. So now let's test it. Print get max of 10 minus 4 and 3. 10. Let's do this. 10, whatever value in the middle is very large. We got it working. Of course, there are many other algorithms how to find the maximum of 3 numbers, like if statement, if A is greater than B and B is greater than C. I prefer this one because it's useful with other lists. Next example, write a function named getMaxMinimum. So this time we need a function that takes 3 digits or 3 integers and returns both. You know, functions in Python can return more than one value. Return both the largest and the smallest. So I'll just get a copy of it here. And now def get max minimum of A, B, C. And first we know the largest now. Let's just do it this way. No return now. Let's do the smallest. We'll do the same thing. Smallest is equal to A if B is less than. If B is less than smallest, then smallest is equal to B. If C is less than smallest, then smallest is equal to C. Your code now, return. You need to know the order, because when you receive them in your main program, you will receive them in this order, largest and smallest. So here I have the code. I'm doing largest first, then smallest. Let us test it. I can say maxi and mini is equal to get max minimum of 10 minus 44 and 999. So print maxi. Okay. And print mini. So let's test it. And we need to know the order again. So this is the largest and this is the smallest. Test it with different values. Okay. Make the last one the lowest one. The first one is the largest and we still get it right. Next is an interesting problem. Write a function to get the maximum digit in a number. So we need to know the maximum digit. So if your number is 678, 8 is the maximum digit. 978, 9 is the maximum digit. Let's say def get max digit of n. Since we talk about digits, we don't care about sign. Digits are from 0 to 9. So we can easily here say max digit is equal to 0, because we know the range of values we are searching for. And the number is n. We will do integer division and modulus by 10. Why? If your number is 345, modulus 10 will give us 5. Good? And 345 integer division 10 will give us 34. So, to get the first digit, we do modulus by 10. To remove the first digit, we do integer division by 10. That's it. To know the digit, we get the first digit modulus 10. خلاص, once we used it, we don't need it. Integer division 10. So now my code is going to be while n is greater than 0. So first digit, let us say, first digit is equal to n modulus 10. Good? So now we know the rightmost digit. If digit is greater than max digit, then max digit is equal to digit. And now we need to go to the next digit. The next digit, we can get it by removing the first or rightmost digit. So we can say n is equal to n integer division 10. In order for us to understand this, I'm going to do a simple print here. This is going to be what? Like this, first digit and digit. And after I divide n by 10, integer division by 10, a new value, which is after removing the first digit. And outside, of course, the function should return max digit. So let us just print it here. Get max digit of 459761. Let's run and see what happens. Good. Let's look at the output. First digit is equal to 1. Is it? Yes, here. So the new max is 1. Then the new value is, here we have a mistake. New value, we print n. Okay, not 1. Let's just run it again. Excellent. Here, first digit is 1. Then 1 is removed. First digit is 6. Then 6 is removed. First digit is 7. And the digit is compared with the maximum. And at the end, we return the largest. In the if statement here, we check if it's larger than the current largest. We replace it or swap them. So, modulus 10 to get the first digit, integer division 10 to remove the first digit. So this function now gets the largest digit in any number. Now it should return 7 here. Yeah, here we get 7. And the output statements here for you just to understand why we did modulus 10 and why we did integer division 10. Next is write a function named SUMDigits that receives an integer n and returns the sum of individual digits. Actually, I wrote this function before this function intentionally because now you know how to get the first digit of any number and how to remove it. So we need sum of digits. We'll get the first digit, add it to total, then get rid of it. So def get sum of digits of n. So let us say total is equal to 0. And again, I'll do the same thing. While n is greater than 0, digit, I'll take the first digit, is equal to n modulus 10. Then I will add this to total plus equal digit. And then n is equal n integer division 10. To get rid of it since it has been used. And now I say return total. So let's see here, print get sum of digits of 678 should be 24, 678, run. 21, sorry, not 24. Yeah, it's correct. Let us just make it complicated. And again, if you want, I can show you the numbers here, or you can just debug the code. So we get the digits one by one, add it to the total, remove it. Next one, until you get zero. You get zero when you do integer division of the last digit. Write a function named count factors of n that returns the number of factors of a given integer. For example, count factors of 12 should return 1, 2, 3, 4, 6, and 12. So all the numbers that is 12 divisible by. So we will just divide 12 by the number. And see, 1 and 12 in this example are considered. So our loop is going to go from 1 to n plus 1. Let's see this. Def count factors of n. So we need to count them. So count is first 0. For loop is fine. For I in range 1 to n plus 1, because we still need n here. So how to count it? If n modulus I is equal 0, means it's divisible by I, which makes it a factor. So count plus equal 1. So every time n is divisible by I, so we increment the counter. That's it. Return count. And let's test it here. Print count factors of 12. And we get 6, which is good. And what I'm going to do here, I'm going to print I. So we know what is the number. So 1, 2, 3, 4, 6. Good. So let me just change it and run it with 15. It should be 1, 3, 5, and 15. 1, 3, 5, and 15, 4 factors. Good. Problem solved. Next is a classic problem, is leap year. And it takes a one parameter year that receives an integer representing a year, returns true if the year is a leap year, and false otherwise. Now let us pay attention to the details. A leap year is divisible by 4, but not by 100. This is 1. It should not be divisible by 100, but it should be divisible by 4. So now we know two things. It should be divisible by 4, not by 100, except when it is also divisible by 400. So here, it should be divisible by 4, but not 100, except if it's divisible by 400. So we can solve it in a simple way. I have seen very complicated solutions for this. So let's do def get or is leap year. Usually the function that returns true or false, we started with is. Is leap year. And here we say year. So one more time. Divisible by 4 on all cases, but not by 100 unless it's divisible by 400. So now, leap, which is equal to true or false now, is equal to year modulus 4 equal 0. This should be true. Good? This is rule number 1. This should be true. And what? One of the two. It's either not divisible by 100 or divisible by 400. So this one or. So we have two options, but one of them should be true. So here I can say year modulus 100 not equal to 0 or year modulus 400 is equal to 0. So now this should be true. And one of these two must be true. One of these two must be true. If any one of them is true, if it's not divisible by 100 or divisible by 400, since we have or in the middle and here, so it should be either true or false, and we get the answer. So here I would say return leap. Leap is going to be a Boolean here, which is true or false. Print is leap year 2000. 2000 is true. 1998 false. 2020 true. 2023 false. So now leap, we made some kind of a Boolean expression, and this must be true, and one of these must be true. Next is a question to find the grade letter of a score of a student in a university. We use simple grading. 90 and up is A, 80 and up is B, C, D, 60, and below 60 is F. Assume the score is a valid value. The question said assume the score is a valid value, so no need for validation. Get grade of score. If score is greater than or equal to 90, I can say return A. LF, it should be only one of them. Score, and again, we are assuming the score is valid, is greater than or equal to 80. Return B. And once you return, your code doesn't complete the remaining parts of the function. Else if greater than or equal to 70, return C. Else if score is greater than or equal to 60, return D. Else, no other choices, return D. So this is our function. We need a colon here. This is our function. We can test it first. Print get score or get grade of 66. We got D. Let's test it with 77. C. 88. 99. This is a typical if statement. So what I'm going to do now, I'm going to reuse the function I created in fun2 to get a value within a certain range in our code. So here, I will go to the top of the code. I'll say import fun2 as F, for example, any name. So now instead of just giving the value, I will say f.get integer range between 0 and 100. So now instead of copying the code from fun2 or anywhere else, I'm importing it and reusing it to get a valid value. If this is a BH example, you can make it 0.14, GPA can make it 0.4, whatever. So now I can get a valid value from a function that validates it, and this function does not validate it because it gets a valid one. So now let's run this. Get a value between 0 and 100, 999 whatever, wrong 44.4, it's valid one, and we get this one. Is it? Something went wrong. Okay. And did we get F? No, I don't see F. Oh, D. why it worked twice? Let us see. I go back to F2, enter a value, while value is less than start or value is greater than end. I don't see a problem here. So let me just reuse it here. F function 11. Okay. I'll just put 88. 88 is B. So what about wrong value? I don't think there was something wrong or... Oh, this is wrong. Enter again. And I'll enter 88. Yeah, it's working fine. So I'll reuse the function from fun2 to get a value within a same range. If you don't remember it, just put the mouse over it. And you see that the function is get integer range. It takes a start and end and returns a float. Next is a prime function. Is prime takes one integer parameter, returns true if the value is prime and false otherwise. Let us say a prime number is a number that is only divisible by 1 and itself. All numbers are divisible by 1 and themselves. If it's divisible by any other number, then it's not a prime number. So what we're going to do? We're going to do this and make sure the number is not divisible by any value. Otherwise, we return false. So def is prime of n. There are more rules, like if it's less than 1 or equal to 1, return false. It's false, and no need to do it. However, there are many ways how to solve it also. For example, here, I can say for I in range 2 to n. No need to divide it by 1. If n modulus I, do you remember the factors example, is equal 0, it means that n is divisible by this factor or by this value. If it's divisible, then the value is not prime. I here can say prime is equal to false and break. Wait, I will solve it in two other ways. Here I would say prime is equal to true. If the number is divisible by anything between 2 and, this is not n minus 1, then prime is equal to false, break, no need to continue. If the number is 15, it's not divisible by 2, but it's divisible by 3. So just make it false and break. No need to continue the loop. Come after the loop, return prime. So prime is either going to be true or false. If the number is 11, it will go from, this loop will go from 2 to 10, but this one will never be found true. So the value of prime remains true. Let us see this now. Print is prime 11. You will see that it would not go inside anything. So true. Now let me just make a comment here. Print f n is divisible by I. So now you know what happens. So if I run this, it did not print that message. It did not go through or it has never been found true. I'll make this now 9. 9, first time 2, it will not be divisible by 2, but 3, it will. So 9 is divisible by 3. No need to continue. Prime is set to false, and that's it. By the way, no need to do these two steps. You can say here, return false. Return false here. If you go inside the if statement, return false, it's the same thing as break, but the code does not continue. Whenever you put return in a function, the function returns from that place and that's it. So now if I run this here, 9 is divisible by 3 and false. You can just do this, or you can make it like this. Even no need to make it prime. Because if you reach line 8, it means there was no return inside the loop. If there was no return inside the loop, then you will reach line 8. However, if there was a return inside the loop, you will never reach line 8. So this function is either going to return true or false. Run. 9 is false. Let me try 13. 13 should be true. It did not go inside. One more thing here. No need to go to n minus 1. Yani for 13, no need to go from 2 to 12. It's enough to go to half of the number. Half of the number, there is no number divisible by more than its half. There is no number divisible by more than its half. However, let us say integer division 2 plus 1 to be in the safe side for some numbers, like, because sometimes you need, for 4, you need to go from 2 to 2, or 5, you need to go from 2 to 3. So just make sure you go to an integer division 2, so we don't need any remainder. So now for 13, it will go from 2 to 7. Why? Because 13 integer division 2 is 6 plus 1, 7. There is no number divisible by more than its half. We are saving some loops here. Sometimes you get a huge number like this. So if it was found only once, no need to go to the end of it. Test it with 19, which is a prime number. True. And 21 is not a prime number. False. You still can see many other solutions about prime numbers, like if the number is negative or something like this. But the core algorithm of this, it should not be visible by any value other than 1 and itself. Next is Armstrong number. And before we explain it, we need to know what an Armstrong number is. The Armstrong number is a number like 153. Look, 153, you have 3 digits, 1 and 5 and 3. The cube of 1 plus the cube of 5 and the cube of 3 is 153, which is equal to the number. Type. Here we make it what? Raised to the power 3. There is another Armstrong number, 9474. Here, how we know if it's a prime number? If the number of digits is 4, we raise each digit to the power of 4. If the number of digits is 5, we raise each digit to the value 5. The total of the digits raised to the power, which is number of digits in the number, should be equal to the number again. And this is called Armstrong number. So clearly here, we need to get the digits by 1 by 1. We need to get the digits 1 by 1. Good? So, how many digits in the number? We need to know how many digits. And we need to raise them to the number of digits. I intentionally gave this question here. I want you to go to the code. And if you remember, we did something like get count of digits in function 4 and get maybe sum of digits or get other things like function 7 get max digits or whatever. So we know how to get the count of digits and we know how to get the digits one by one. So in order to solve this problem, we need to know the count of digits. Then we go and do the total. The total should be equal to the same number. So let's say here, def is Armstrong n, and we should return true or false. So let's say here, count or total is equal to 0. If you recall, I made a copy of some numbers avoiding to lose their value. Here, I will say x is equal to n. Why I would do that? Because I will need n after the end of the loop. So now let us say, or let us try to find how many digits in n. I can call the function or copy it, count digits in fun4. So I will go here. I would say digits equal, let us import it first, import fun4 as f. So f dot count digits of n. So now I know the digits of n. How many digits in n? That's it. Now I need to get the digits of n one by one and raise them to the power digits. So total is 0, while we did this loop before. While n is not equal to 0, we need the first digit. So d is equal to n modulus 10. So we get the first digit. Total is equal to d star digits. It seems there is a mistake here, digits. So we raise it to digits. And then I need to remove the digits. So n is equal, I prefer to use x here. As a programmer, I prefer to use x. N is here, okay. X is equal to x integer division 10. So we get rid of the digits one by one. After the loop, I will compare total to n. If total is equal n, return true. Else, return false. So now here, I know how many digits from count digits function. I get the first digit, raise it to the power of number of digits, and then get rid of it and go back until x is equal 0. Let me test this with a known number. Is Armstrong 153 is a well-known Armstrong number. I get false. Maybe there is something wrong here. Okay. No, I don't think I'm running this. Okay. Oh, maybe here. No, print here. Fun4. I did print here in fun4. Let me remove it. I did print while explaining. No need to do this here. Save everything. So let us see here what we get. I get false. What is 6 here? Why I'm getting 6? Let us see here. I think I need to save again. Count x is equal to n while x is, oh, here, x modulus. Yeah, that's it. X modulus 10. And, oh, sorry, no. Okay. Let's just keep it here. I made a mistake. I went, okay, digit is, here, I need to replace it with X, I believe. Now run, 153. Let me see what I made a mistake. Digits equal, that's it. No problem here since we are not making any changes. X total plus, total plus equal. Okay. It should be true. Yeah, true. That's it. I still don't know where we get 6 from. Let me see where we get 6 from. Where is 6 here? Is Armstrong fun for? Oh, yeah, maybe Brent. Okay, here, count 6. Okay, I don't know where I get 6 from. Let me try with another Armstrong number and this 9474. Let me try, make sure it's correct. Okay, let me give it any other number. These I know, okay. And here, false, good. So now I have one problem, which is where I get 6 from. If total is equal n, before I reach 6, I can here save 2-3 lines. I can say return total equal n. And this is a classic example where I needed to make a copy of n because the value of n will be changed inside the loop. I still need it after the loop to compare it with total. Run here with 153. So where we get 6 from, I really don't know. I think I need to go to fun4, count digits. Okay, let me just remove this here, yeah, from the Brent here. Okay, and now we get it working fine. That was from the other code. It's now just a function, and here we are using it. Using isPrime function, print the prime numbers between 1 and 100. Very simple question. We did the prime number before in F12. بس خلاص. I'll use it from F12. Import F12 as P prime. No, that's not F12. Fun12, sorry. Good. بس خلاص. So now I need to print the prime numbers between 1 and 100 for I in range 1 to 101. If P is prime of I, if this returns true, print I. That's it. So no need to make spaghetti code here by doing the prime code again inside the loop. We just reuse it. And this is once you finish functions and other parts, you know what is called reuse. So here I'm just reusing it. And if it's true, I print them, otherwise no. So let me just go back there and remove some messages I used for debugging and for explanation. Now no need for them. And this there was a problem here. Yeah, here. Remove this line only. So now I'll go to this code so these are the prime numbers. 1, 2, 3, 5, 7, all are prime. Yes, this is correct. 97 is also a prime number. So this is a good example of code reuse. Next one is also another example. Using isPrime function, print the first 15 prime number. Here we don't have a range. We just need to keep doing this until we reach 15 prime numbers. So we just need to maintain a counter. We need to maintain a counter. So let us see how we gonna do. Def print first primes. And as you see here, import fun12. So let's say count, we need to know when to stop. Count is equal 0, n is equal to 2. Because we will start from 2. 1 is not a prime number. Good. That's it. Now I will call the function is prime. But as long as the count is less than 15. So while count is less than 15, keep doing this. If P is prime, n count plus equal 1, and I need to print it. Print n. And after I check, I need to go to the next value, n plus equal 1. And if 2 is prime, go to 3, go to 4, until you reach what? 15. Until you reach 15 primes. This value is incremented only if the value is prime. So I'll just change it to 100. That's it. We are done. So we call the function, increment the counter and print the number and go to the next value. Our counter here is the prime number. There is no return here. Let me just call the function. Print first primes. That's it. Run. So these are the first 100 prime numbers. The question was 15. And I honestly don't like these questions. I will say here number. Now I will not make it like this. I will call the function, give me the first 200 prime numbers. Look at this now. I made it a parameter. I send the argument when I call the function. And now I see the first 200 or even whatever. I like to make the code general. And this is one reason why we need to learn functions. Using the is_Armstrong function, we did this. Print the Armstrong numbers between 1 and 1000. We did this. Let us see it. As you see here, I'm importing fun13, which is the is_Armstrong, which uses count digits also. And now I need to find the Armstrong numbers between what? 1 and 1000. So now def print arm range. I don't recall what was the function name. So now I'll say for I in range 1 to 1001, if arm is Armstrong I, is Armstrong I, then print I. That's it. So just call the function. We did all the code there. So now I'll just print arm range and let me run the code here. I get this. Let me clear everything. CLS, run the code. We have these numbers are Armstrong numbers. The next example is print the first 15 Armstrong numbers. So first 15 is not a range. It's exactly what we did to is prime. Import it. Okay, I'll just make here def print arms count. And here I'll say X. I'll just change it, not 15. I'll just make it first X. Okay. So now import it for this is no range now. Count is equal to 0. And arm, we need to just start from 1. N is equal to 1. And while count is less than X, we made it a variable. If arm, is Armstrong n, So first of all, count plus equal 1, and we need to go print the value, print n, and here I need to increment n to go to the next value. So this is going to print X Armstrong numbers. I'll print the first 100. This might not be an easy thing to achieve. See, the program became very slow because it's testing. Since I'm recording, I'll not waste time. I'll just make it first 15 and run. So count, print the value, go to the next value, keep doing this. You stop when you reach the count, not when you reach a range like the previous example. Write a function that is named next prime. Next prime. What is next prime? You send a value to the function, returns the smallest prime number greater than a given integer. So let us say 11 is prime number. Next prime is going to be 13. The closest value is not going to be 29. The next prime. So let's see how we're going to do this. We're still going to use the functions we defined before. As you see here, I am importing the prime function from fun12. Remember, the question says, get next prime, def get next, I like camel case naming, after n. So we know n is a prime value, so we need to start from the value next to n. So let me say n plus equal 1. Now, if n plus equal 1 is not a prime, I need to go to the next one. I'll stop the first time I find a prime number next to n. The example I gave you, 11 is a prime number. 12 is not. Go to 13. 13 is a prime. Yes, stop. And return 13. So see what I'm going to do here. While not is prime, sorry, P is prime, while not P is prime, N, if it's not, is prime. If this is false, this will be true. So it means the number is not prime. So increment n. Go to the next n. If 12 is not prime, go to 13 and come back. This loop will end when the is prime returns a true value, because not true will be false. So not true will be false. Then if you reach line 7, it means n is a prime number. Just return it. I'll give you the example with 11 and 12. You send 11. You test 12. While not is prime 12, it will be false. Not false means true. So we'll go inside the loop. Increment n. Go again to line 5. Next is prime 13. Oh, this will be true. So not true is false. So it will skip line 6, or it will come out of the loop and return it. Let me just test it here. Brent, get next prime 11. Let's see, we need to get 13 here. Excellent. Type 13. We need to get 17. Let us see this. Mumtaz. And 17, 19 is the next one. 19, maybe 23 after 19. So you keep trying. So let me show you some output here. Brent, F, N is not a prime number. Going to test n plus 1. So this is just an output. يلا here. 20 is not a prime number. So increment it. 21 is not 22. Oh, 23 is a prime number. Hopefully we solve this problem. This is a very efficient loop. You want to keep trying until you get it. So you can use while not. We rarely use this in the classrooms, but this example is a good one to explain it. Write a function named decimal to binary that converts given decimal number to its binary representation and returns it as a string. First of all, this is just additional question. And in this question, we will not be working by numbers, but we will be working by strings. So let me just go through the code and show you how to do it. Here is our function. Let's say binary is equal empty string. See, it's like I'm not going to return a number. I'm going to return a string of 0 and 1. If you don't know how we calculate binary, usually we're calculating by dividing the number by 2, the decimal number by 2, and then if there is a remainder or there is no remainder, we take 1 and 0 until the value is 0. So it's very similar to what we did before, but now we are dividing n by 2, and we will stop when n becomes 0, so while n is greater than 0. Here I will say binary is equal to str string n modulus 2. Actually, plus binary. And I know you might not get it here. Then n integer division 2, not 10. Because with binary, we keep doing integer division by 2, not by 10. Binary numbering system. Return binary. What I'm going to do here, I will show you here print binary. What is happening? And I will give you a number like any number. Print decimal to binary. Let me book 67 or 47. That's fine. Run. 1, 1, 1, 1, 1, 1, 1, 1, 1. Then you have 0. Okay, because there was no remainder. Then you have 1 because there is a remainder. I'm not going to go through how to convert decimal to binary. But in this, instead of dividing by 10, we divide by 2. If there is a remainder, we use 1. If there is no remainder, we put 0, and we stop when we reach 0, the original value. Let me just make a number like 251. Run. And this is 251, correct. Okay, 255, for example, 8 ones. Okay, 128 is 1 and 7 zeros. Good, excellent. So here we use the string. We use string concatenation. We do the division or modulus by 2. If it's, let me just give you 17 and explain 17 here. Explain 17. 17 modulus 1, 1. So we keep 1. And the result is 8. 8 modulus 0 is 0. And the result is 4, division. So they keep doing this until they reach 0. And here we reach 0. If you don't know how to divide or how to get a binary, you will not understand it. Unfortunately, there is no time to explain it here. I'm just doing it as a string. Remember, I'm doing modulus 2, get the 1 or 0. That's it. Last question here. Write a function named is a strong number that receives an integer and returns true if the number is a strong number and false otherwise. طبعا your question now, what's a strong number? A strong number is a number for which the sum of factorials of its digits is equal to the number itself. 145 is a strong number because the sum of factorial of 1 and factorial of 4, factorial of 5 is equal to the number itself. So we know how to get the digits one by one. We know how to do that. And we will write this code. We need a factorial function. I prefer to make a function instead of a loop inside a loop. I prefer to make a function in the code. Let's see the code. First, I'll make a factorial function, def get fact of n. Fact is equal to 1 for I in range 2n plus 1. Fact times equal I. Return fact. So this function is going to be very helpful. We're going to get the values and from it instead of putting a loop inside a loop, because we need another loop to get the digits one by one. The function, the main function is going to be is strong number. This one is going to return true or false. N. And in this one again, I'll say x is equal to n and total is equal to 0. You remember we did this with another type of problems. We did exactly the same. We copied the value and used the total. So now we need the first digits. So while x is greater than 0, or you can say x even is not equal to 0. In this case, it's the same. So we need the first digit. First digit is equal x modulus 10. So this is our first digit. The good thing now here, I need to use the factorial function, which is there. So here I can say total plus equal get factorial of d. Good. So I get the factorial of the first digit, add it to total. Now it's time to get rid of the digit. So I say x is equal to x integer division 10. This is how we get rid of the first digit. So here we get the first digit, get its factorial, add it to total, remove the digit, come back to the next digit. And that's it. What we gonna return here? Return total equal n. If the total of the factorials of the digits is equal to the number itself, then this is called a strong number. So let's see an example. 145 is a strong number. Let us test it here. Brent is a strong number. 145. Hopefully we get true. Perfect. Let us try another one. 541. Let me just get some strong numbers. I know another strong number, which is 4585. And if we get through here, perfect, we get through. So our solution is correct. And I believe the solution is simple because we did a factorial in a separate function. We used it instead of loops. And here we already practiced how to get the first digit, how to get rid of it. And finally, we compared the total to n. We made a copy of n here to x. When we were dividing x, not n, so at the end, I still need n. So in here, in this example, it's a must to use this. Hopefully, you learned from those 20 functions. Most of them are numerical and algorithmic functions. Once you go to files, lists, dictionaries, you'll find that you will never go back to your code before writing functions. Programmers write code using functions.